Hello, everyone. Today we're going to be talking about a concept on improving security operations through security data discipline. Just quickly, without going into depth on my background, the concept you're about to hear me describe is really based on a range of experiences in government, in financial services, and in consulting. But I'd hold three out as really important. The first is while I served in the Air Force, I led the Air Force's cybersecurity operations group and also the Air Force's Red Team. So I believe that, gave me a strong understanding, back at those times exactly what defenders needed to be looking for and also the types of things that attackers would do in order to hide themselves as they went after networks and data. In the period after I served, I also had the opportunity to help the Japanese National Computer Emergency Response Team develop a program, including a training program and a range, to look for advanced persistent threats. That was at the time frame when that terminology was kind of just beginning to be used and people were starting to understand there were adversary groups that needed to be looked for specifically, and we very much focused on the notion that was then emerging of indicators of compromise and how to look through data in the tools that they had in order to find the right, the attackers and, to provide the right alerting. And then finally, as the Global Chief Information Security Officer for JP Morgan Chase, we set up three security operations centers, basically full up centers in three locations around the globe that were able to take over the defense of the entire corporation at any given point in time. We used it 24/7 and really dug deep into the tooling that we needed, the SIEMs and other sorts of displays and query systems that we use for our analysts, and also had to struggle with, and as I'll describe, the increasing complexity of the environment. That's a very large environment. Actually, JP Morgan is approximately the same size employee-wise and network-wise as the Air Force. So, based on these experiences, I'll go to the next slide. I see the rising challenge, for me, over approximately a 20-year period of, security operations in an environment where technology is becoming, not just more complex, but more devices, moving more data through different types of networks and feeds, all of this servicing great, gains in terms of flexibility and agility of technology, the ability to do things that even 10, 15 years ago we never would have expected. But there's, the amount of data and the different formats that it moves in and the complexity of it is, sort of shifted upward dramatically as the technology has become more capable of moving it and therefore to sort through it. We've also increased the number of tools that we use in order to find attackers, and then finally, the attackers themselves have increased in number, in sophistication, in the different sorts of things that they do and the different sorts of technology they attack, again requiring defenders to use an increasing array of technologies and data feeds in order to find them. So if you put these things together, and the slide just begins to describe, the number of arrows and the velocity and size of those, data streams heading towards security teams is dramatically increasing, is increasing, as we speak. This past year, 2020, probably, I would imagine when we go back and measure it, would have been the largest increase, we've ever seen as particularly workforces shifted to remote work. Security teams had to cover that work. Again, all the challenges I just outlined being accelerated by the shift into remote work. So actually, just as this proposition, the COVID situation came upon us, we put together a proposition here in NextPeak, my new consulting group, with a set of people that actually are security operators, lead hunt sorts of functionalities, are the type of people that for, again, over a 10, 15, 20-year period have been on the front lines looking through data in order to find adversaries, whether it's in an operations center or actively looking in a hunt sort of operation. What we believe we can do is take two sorts of filters. One filter is technical, and putting the right sort of pipeline tools in front of all the data sources, and we'll talk a little bit more about this, and structuring the data, removing elements of data feeds that are not essential to any sort of security monitoring and alerting, or at least putting them in cold storage so that they don't have to be actively used in query systems or stored in high-cost data indexing systems. Those technologies now exist. At one point in time, we actually thought about building filters, but we believe there's a variety of good filters out there in the market that can be used to perform the technical functions here. What we are combining that with, and I'll talk a little bit about an initiative we have with Mitre, is the attack framework, which, as a net defender, I think is one of the most important developments of the last, probably 5 years, but, it is increasingly an industry approach that's, pulls together the insight and expertise of the entire community in order to provide information about how to find attackers. And if you combine that with the right sort of awareness on your own side, on the defense side, the ability to leverage the attack framework and extend the attack framework to tell you what sort of data and what structure of data you need, I think it can be very powerful. So, I've hinted at this. This just puts a little bit more, fidelity or specificity to it. Data complexity for a security operations team both increases cost, and I think it increases risks that things that need to be found won't be found. Very directly, and we've got some figures later in the brief, the size of data volumes, 1 to 6 terabytes a day at large enterprises, creates very high indexing and retention costs. Also, if you do not reduce that data, it can actually significantly slow down tools, queries that are used to find attackers, as hopefully most on the call would be well aware of. It also, given our ability to store large amounts of data and do that without discipline, the poor visibility into the low quality of data sources often gets hidden in the fact that we can create very large data lakes, even if we're willing to spend the money, to sustain those lakes. We're not quite sure the quality of the data within them. That's because we don't discipline the pipeline coming into the places where we use SIEMs and the data lakes and sources that we have for those. And, we don't respond well, in terms of transient failure states. Then the costs, when the nature of data changes rapidly because a device, suddenly is producing at a different rate, we don't really understand that. And again, costs can spike as, the feeds into the data lake change very rapidly. So how can data discipline help? And, I've more than hinted at it, I've sort of talked about a few things, but, reducing data volume through filtering events and parsing out the unnecessary and useless fields while retaining high-quality data is sort of the entry proposition here. And we've done this in a couple cases, and we'll show you some of the results. It reduces the overall number of events, particularly, hopefully, false positive events, and, the size of the data that you're wrangling in your data lakes. We also can improve data quality and increase analytic effectiveness. The workload in terms of the automated tools that are used in a SOC or through a SIEM can be decreased. The speed of queries and extraction and normalization of data can be increased. This clearly leads to improved time in terms of effectiveness and responsiveness. in the SOC, where the sort of central workflow metric is how long it takes to process a query, and the reduction of false positives is also sort of directly related to the saving of time. And finally, that can make new technology adoption much easier if you use the right sort of filtering or pipeline technology, and you can plug new feeds into a pipeline, have expectations about how those feeds are now being integrated into your security operations. You can move between a more vendor neutral set of tools as you use the pipeline to rapidly allow you to either shift off of or shift on to new tools. If we look at some of the findings we've had in our work, a later slide actually talks about the pilot we did, but the pilot does provide these findings. The pilot was with MSSP, a small MSSP, where we took the data that they were bringing into their operations, and we found that we were able to achieve some pretty significant gains in terms of saving both storage size, but also storage amount as well as cost. Even with no loss of sort of information that we're feeding, any sort of tools that would cause any sort of risk trade-offs, so we were able to achieve a 15% reduction. With a little bit more trade-offs, mostly just not duplicating data, for multiple, storage locations, we were able to up that savings to 40 to 60% of the data that flowed through the security pipeline that this MSSP was using. And we calculated that, if an organization is saving a petabyte of data using normal sort of current cloud storage costs, this could be approximately $1 million a year. And we know from work with large enterprises, a petabyte of data is, not an abnormal figure. And for very large enterprises, that's probably low to almost an order of magnitude in terms of the amount of data that they're handling. If you combine the work that we've just described in terms of using a pipeline and removing fields and data that's unnecessary with the Mitre attack framework, we feel like even more power and more direct sort of analytical and operational effectiveness in terms of finding bad guys in the network can be achieved. And really the notion here is, if Mitre provides good guide to the nature of the techniques that the attackers are using and what needs to be looked for in the data feeds coming towards a SIEM, you can start to make community type of decisions about the normal sets of tools that are out there, and within those tools and the data feeds that they provide, how to take out things that are not necessary, how to fine-tune those tools so that they feed your SIEM in a more effective fashion. And we've begun to talk with the team that develops the Mitre attack framework about putting more robust guidance into the Mitre framework in terms of blue data and the types of things that defenders should specifically be looking for, and what tools provide those data sources, and what discipline can be instituted in those data feeds. So where we are today here in NextPeak, the consulting group that I have, and where we've sort of honed this data discipline initiative, is we put it together basically in the spring, lived through the onset of COVID here in New York City as part of the New York City Cyber Accelerator, and played through the proposition and tested it out, as I described, with a partner MSSP that we work with. We're also initiating a second wave of analysis on the standard Windows Active Directory and logs with a data set that we have, and playing through the degree to which we can reduce that data without any loss of security and hopefully achieve the gains in both cost and effective queries and security operations. Next step, we hope, especially with the community that I hope is viewing this briefing, is to build an open source community effort to develop the concept further. We want to work, as I mentioned, with the Mitre Framework community in looking at the right sorts of data feeds that come off the tools that would be naturally used in countering the attacks laid out in the Mitre Framework. So with that, I'll stop and take any questions. Thank you very much for the opportunity to talk to you.
Okay, now I'd like to welcome in Dr. Greg Reynolds. Greg, thank you for the terrific talk. Welcome to FlowCon.
Glad to be here. Appreciate the opportunity.
And we've got lots of great questions coming in for you, so let's get to them now. First one came in from Zoom. Greg asking, what types of data are you filtering? NetFlow or something else?
Generally something else. The power, we think, really comes from those situations where everything is going into your security analytics, from firewalls to application logs. I mean, you could apply the concept to NetFlow, but we're really looking more at sort of devices out at the endpoint and their logging functions as a general proposition.
Okay, question from Discord asking, can you share your thoughts on the relationship between various degrees of good/bad data discipline and accumulation of technical debt?
I think there's probably a fairly straightforward correlation. If what we mean by technical debt is the challenge of consistently, rapidly upgrading technology, we all especially in larger enterprises, you're using a lot of legacy technology. So at least in my experience, that tends to be what we're talking about with technical debt. And, it's hard to offboard that stuff because you're using it effectively. Therefore, so I believe there's probably a proportionality of more bad data coming from older devices, or in a sense, bad is maybe not the right word, but less relevant data per gigabyte is in a older stream than is in a newer stream. So as you accumulate technical debt, the percentage of data that's not useful is increasing, and therefore the importance of data discipline is even higher. I will probably add the thought that the same things that would challenge you in terms of reducing technical debt are the same sort of skill sets that you would have to apply to data discipline, so that the two things are conjoined in the sense that you don't want to, like the team that has to get rid of the bad old technical debt is the same team that you need to use to probably focus on the data discipline proposition.
Okay, thank you for that, Greg. Next up in the queue we had, how would the SolarWinds situation apply to the concept of data discipline?
So, with SolarWinds, I mean, one thing that is important to me, and I've spent a lot of time talking to people about this in the macro perspective, is to understand that what SolarWinds is allows elegant access to a wide variety of, in this case, customers of a particular software package that would be updated. And this is an endemic supply chain challenge. So that, while SolarWinds is one particular, identified, software package you're using that might have updates in it that allowed a bad actor to get inside, what we would, to me, in the very strategic sense, is supply chain attacks are, again, proven to be very effective and elegant. Therefore, right, that your security challenge includes the fact that adversaries will get in. So it's not just, and probably needs, it's increasingly a lateral movement, understand how to find known bad activity that is occurring inside your network, because the adversary will be able to get in. So when you apply that to apply the SolarWinds type of supply chain attack to data discipline, what I think you want to be looking at is back to that Mitre attack thought pattern, which is, okay, if we know these sorts of actors do lateral movement in a certain way, we know, therefore, what their movements will look like. We know which sorts of devices in our network will detect those movements. You want to filter down and bring forward the things that would be, the data that's going to highlight those attacks. And again, if you go through the whole pattern, the whole thought structure of, I know now what I really want to look for in my security data, you can use the filters to make sure that you've got the right data in your SIEM when you're looking for it.
Okay, we got about 5 minutes left, Greg. So we got 2 more questions from Discord we'd like to get through, if okay with you. The first one being, can you please share more detail on how you filter data at scale without deleting valuable data, and is your filtering dynamic?
So I'll take that in 2 parts. The first part of it is that essential judgment call about like what is valuable data. So a couple propositions. Think about an example that we've worked with, a firewall log. There are sets of things in a 100-field firewall log that are clearly absolutely irrelevant to any sort of security query. So you literally inside the fields in a log, you have to do the analysis, but you can drop things that are just telemetry that doesn't relate to security. Then there's this interesting large impact decision about duplication. And one of the things that we've been working on is which of the data do you store where? Do you store it in cheaper cold storage so that if you're in a forensic situation, you can go find it, where you need more granular data? You might want to have a lot more data to find the needle in the haystack for, versus the things that are feeding your SIEM and alerting. You think about a situation where you're using Splunk and you're paying pretty high costs for data indexing. So there's decisions around where to store data, not necessarily filtering it out. But I do think this is empowered by people. The valuable data judgment is an experientially based judgment. In terms of the filtering dynamic, eventually one can conceive of AI helping drive, changes to the filter. I would say that, that's not the current state of the art, that the filtering needs to be, a decision of the security team about which feeds they want, what should be in the feed, which feeds go into more warm or cold storage, for different use cases. That really, I'll just say that most people are making almost no judgment and just dumping everything into storage bins. And again, I think there's a wasteful and slow you down aspect to that.
Great. So we got about 2 minutes. So we're going to work on one more question, Greg, if that's okay. And this one's from Ed on Discord asking, from your experience, do you see any operational difference between commercial BI or buy data, storage/index/query solutions, and security-specific data storage/index/query solutions? For example, security-specific solutions cost, dollars for TB cost is 1 to 2, the order of magnitude larger than commercial solutions.
So if I've got the question right, hopefully I'll be close on this. Technologically, I actually think that the technology, we've been using in our pilots for filtering is actually designed initially to be a business intelligence filter, and we're just using the capabilities of parsing the data streams that technology has. And we were thinking about building our own technology, and we decided against it because we think the filtering technology that has already emerged for business intelligence and large data sets is good. It's it's effectively the algorithm or the decisions about what to filter and how, or in a specific feed off a device, what fields to take out so that you're not having it flow through to a data lake that you're using. If I got the question right, I think technologically you can use the same filtering technology that the business intelligence and other analytics, data management processes use, but you've got to have a different, you've got to have expertise in security and the security use case to decide what in the data streams you do filter out.
So that is a question from Discord. So please be sure to check out your channel there, and you'll be able to access that one and a couple other, Greg. But we're out of time. But thank you very much for sharing your expertise here at FlowCon.
Yeah, I appreciate the opportunity, and everybody be well. Take care.
Thank you.